squared circumference?
Pi r squared.
2 pi r.
2 pi r.
Thank you, Jaden.
Thank you. Right.
Okay, what else can we calculate here?
The
Diameter.
volume.
Area. Okay, I heard diameter. So the area is
Pi r squared.
no, they're round.
That.
Good. Yes, no math. What else can we calculate here?
Half of a radius.
Probably something you haven't really studied much, but will come up on your standardized tests. Sector area. I've mentioned this, right? It's an angle measure, right?
Yeah.
So it's the angle measure over 360 times pi r squared. It's just a fraction of pi r squared, right? How big is your slice of pizza? Oh, that's why I like circles. They make really good food.
Okay.
We can also do arc length. Which is the same ratio times the circumference this time. So, lots of things you know about circles, hopefully. The 3 top ones I would expect, the 2 bottom ones. I would hope you know it, but I would not expect it.
What is r length?
Arc. ARC. Anything else you can think of? Besides the unit circle, I'm not drawing that up here. Our favorite.
No.
So 0 or take over 360 times pi r squared. Take over 360 2 pi r.
Okay, so we have all this information about circles. The unit circle, we know, and it's the first time we've plotted a circle in the coordinate grid, right?
Oh, yes, okay.
What's the radius of the unit circle?
Just kidding.
Radius.
I don't know.
Yeah, 1. Okay.
Wait, we just learned another one.
Our entire study of circles, this chapter, is plotting them in the coordinate plane. Okay? The unit circle equation, so you've got an equation for a circle, much like you have an equation for a line or a parabola. The unit circle equation is that right there.
Why does that look so
Because it is. Let's just be real here. There are 2 pieces of information that this equation can tell you. The center, where's the center of that circle located?
0, 0.
Bet. Okay, and then so that's the location of the circle, and then the size of it, the radius is 1.
That's described.
That's the unit circle. That specific one. Now, here's something that you might know from the unit circle. What are the x values of the coordinates? Cosine x squared plus sine squared is 1. So an identity. This is where the identity comes from. Sine squared plus cosine squared. All right. If I'm gonna write this in the format that we're gonna study, here's the same equation.
One.
So I.
There's a point.
Okay, I'm like, why?
Yeah.
What does this tell us? Where the center is.
Yeah.
So if the center is not 0, 0, there's gonna be numbers here.
Yeah.
Right? Okay. What does this tell me? The radius. It will always be r squared. R.
Ethan.
Today, maybe. It always tells us that this is 1 because 1 squared is 1. This is the general form of an equation for a circle. So translate now. What are H and K? Or center, right? So here's the general form of a circle equation. Center HK. Radius is
Squared.
just r. Radius is r. So the number here, if this is 36, what's the radius? 6. So that's a circle. In a nutshell. I want to show you one. We'll write the equation. And I'll show you a real world app. It'll be good.
Real world app.
Like I said, we can make this a lot more complicated by foiling both of these out and making it a bigger mess. But I want to focus on just this standard.
So that's the
form.
answer though? Right there?
What?
X minus 0 and all that? That's the answer?
This.
The top one, yeah.
No.
That's the answer?
This is okay actually. I don't want the zeros in there.
Oh, okay.
But I built the form on this.
Oh.
Circle. Basic.
So when we have like actual numbers like for x and h and y and k, do you want us to FOIL it or just like
No, leave it.
like that?
Yes, like I said, I want to keep it easy. Yep. Give me your best shot. So we can go either way. I can give you a circle and ask you to write the equation, or I can give you an equation and ask you to graph it, right? So either way. Welcome to try. You say a lot. Yeah, we just need to fill in the information. So what's the center? So x minus what? And what's the radius? No, it's not equal to x value every time. Be careful there. That's it.
That's it? I mean, why isn't
3 squared is 9. You can write it if you want. There's your equation for that circle. That's as far as I want you to go.
Can I start?
appreciate that I'm not asking you to take this one step further.
Okay. Yeah, I'll keep up with that. What's
The hard part of this is I could give you an equation completely FOIL and ask you to work backwards to find this equation by completing the square and then graph it. Great question. I'm not doing that.
Is that why there's complete history?
No, that wasn't either in school. We'll just in practice. Okay, so this is it. You're good. Okay? You can go either direction.
And we have to find the right? And that's
You
because,
have to count. Can you count? Right?
yeah.
Very good. Okay. We will get into this algebraically.
tomorrow?
The application that I want to show you is earthquakes. I kind of gave you a little primer for that right? Algebraically, it's a little more involved graphically. See that again? Oh, you can do that. Right. You can use the distance formula. If you need to use the distance formula to find radius, you can. Okay, here you go. An earthquake is struck.
Okay.
Scientists have calculated that it was 210 miles from Fort Collins. Yeah. And 175 miles from Salt Lake City. Where did the earthquake strike?
What
Possible strike. There are two options.
We're gonna get this.
This is a very straightforward problem involving circles. Okay. The scale is 35 miles. So find 210 miles from Fort Collins. Where am I going to stop? 35, 70, 140, 210. So I got a possible point here, but it's going to form a circle because it can be anywhere within 210 miles of Fort Collins.
Yeah.
Right? Oh, and then I draw this.
So then you do your dot and then draw the line.
Probably not.
And then you do it again,
Yeah,
Salt
so
Lake
there's a-
City, and then you find where they intersect, right?
I was-
I was right.
Oh, that's not a bad idea. Here we are wasting time. The scale's not there.
Dry number scale.
Okay, here, let's just give you the idea. Okay, we're about 210 miles from Fort Collins. How far?
175 from Salt Lake.
It was just to the right of her. So, somewhere in there. This would be the circle of all the possible locations that are played, right? And it would go out east as well. Lake City. 175.
Yeah.
70, 140, 175. So out here. And here's a circle. All the possible Salt Lake City locations. What are the two possible earthquake locations?
Yeah.
And if you had a third,
If you did out a third circle, like Laramie or Rock Springs, we would figure out which of these two is the location of the circle. So, again, we'll get into that with the algebraic aspects. And I'm tossing around some sort of project there in my head. I just can't do it. It's not like it's free stuff if you're into it. It's called free stuff if you're not into it. Okay, I think that's all I got. So I'm asking you to graph circles and to write equations. Good enough? Okay. You might have to do some circle areas and stuff, but yeah, I expect you to know that. Write that down. I'm going to give you about 10 seconds. I have one more thing to show you. That's a resource for you. Is this just a resource? No, that's your homework. Okay. I have one more thing to show you. That's a resource. Okay. On Google Classroom, I have posted a couple of conics. Tables. These are available to you. So these are basically what we're going to look at. The circle we did today, right? Here's the equation. And here's the picture. And there's no vertical or horizontal difference for it. But as we get into ellipses, tomorrow you can see that ellipses have vertical or horizontal options. There are actually diagonal options as well. Parabolas, you can go horizontal or vertical. You know the vertical very well. So, and then hyperbola is the same. So here's a resource that's posted to your classroom. And there are a couple of them actually. But use those. It's a little easier than looking through your